Welcome back to Tina Turtle. In our last video, we learned how to set index values and use the index variable in the body of a loop. We also played with different values to see how they change the design. Let's make this play a little more formal. Good programs are structured to make editing easy and systematic. In this video, we will learn how to write and use parametric variables. Let's run this code. As you can see, it makes a Swiss cross. Each side is 40 units long, and we repeat that command 1, 2, 3, 4 times. If we want to change these lengths, we need to revise tina.go 40 3 times. This can become a very messy process in large programs and easily leads to mistakes. Instead, we can define a parametric variable before we run the loop. Let's call it s for side. Now we have defined the parametric value for s in just one line, s equals 40. We replace each instance of 40 in the body of the loop with s. The cross is exactly as before. The program used the defined value of s. To make a smaller cross, we simply change the parametric value. Let's try s equals 20. Now we can make the cross any size we like by just changing one number in one line of code. Very clean. We can define as many parametric variables as we need in our program. Let's see how this works with regular polygons. We'll start by erasing the last 3 lines in the body of the loop. This is our basic square. Remember that we can define the angle as 360 degrees divided by the number of sides. We'll change 90 to 360 divided by 4 to check that. And it produces the same result. Now let's change the 4 to a variable n. We write n equals 4 before the loop to define the parameter. Then we change the range to n and the left turn to 360 divided by n. Once again, we have our square. Now let's assign a different value to n. How about 3? Our polygon is now a triangle with 3 sides and a turning angle of 360 divided by 3, or 120 degrees. Let's change both s and n this time. S equals 20, n equals 10. The result is a decagon with shorter sides. We have written an algorithm that will create any regular polygon of any size. All we need to do is change the values of s and n to vary the result. We don't need to touch the for loop at all. We have created an algorithm that is efficient, flexible, and less prone to errors. Parametric variables allow us to change the outcomes easily without disturbing the program. Remember to define the parametric variable before the for loop and write the variable name or letter within the loop wherever it is used. This includes the range index and the body of the loop. In our next video, we will learn how to write functions. In the meantime, look at the numbers in programs and see if they can be defined as variables instead. Practice makes perfect.